Bright QT. Every student matters.
Let us see a few questions that will be asked in the examination based on this particular topic. A bit of the numericals we will see. Fine. Let us relate. Alright. A few things you need to remember while doing this particular numerical part is, we have talked about charges, right? You remember the positive and the negative charges. We talked about electrons represented like this, protons represented like this. Now, we also need to know what exactly is the charge on a particular electron or a particular proton. Fine. The charge on an electron or a proton is, when we talk about electrons, it is 1.6 into 10 to the power minus 19 Coulomb charge, right. So, the charge on an electron is 1.6 into 10 to the power minus 19 coulombs, and the charge on a proton is strangely the same, 1.6 into 10 to the power minus 19 coulombs. You have studied earlier in 9th class that the charges, equal and opposite charges are present in an atom. The electron and protons, they carry an equal and opposite charge. Now, the charge on both of the particles, electrons and protons, is same. The difference is, on an electron, this is a negative 1.6 into 10 to the power minus 19 Coulomb charge, and on a proton it is a positive 1.6 into 10 to the power minus 19 Coulomb charge. Now, some students tend to make or tend to have a mistake out here, that is, they consider that if it is an electron, the charge will be 10 to the power minus 19 coulombs, and in the case of protons, the charge will be 10 to the power plus 19 coulombs. That minus and plus are not over here on the 10 to the power raised values, but it is in front of it. So, you need to make a differentiation and distinction between them, that the charges are basically like electron and proton, they are minus and plus here, right. Keeping this thing in mind, we will be attempting our first numerical, and that first numerical in itself asks us calculate the number of electrons constituting 1 Coulomb of charge. Now, what we are required to calculate, first of all, try to relate that. We have seen that the amount of charge given to us is 1 Coulomb. So, I will say that Q is given to me, that is 1 Coulomb charge. Fine. What I need to say is that how many electrons will be together constituting to carry this particular charge. Now, to attempt this question, it is a very simple question. To attempt this question, we just need to apply simply unitary method. Now, what does this unitary method state? This unitary method states that if the charge on one electron is these many coulombs, minus 1.6 into 10 to the power minus 19 coulombs, then for 1 Coulomb of charge, how many electrons will come together? So, what we will do is, we will just take this value over here. Let us see how to calculate it. Let us see how to solve it. In this, what exactly was given in the question? We have to calculate the number of electrons. Now, what I will start with is, we know that the charge on one electron is equal to 1.6 into 10 to the power minus 19 coulombs. Fine. So, if one electron has this much of charge, then for getting 1 Coulomb of charge, how many electrons I will be requiring? I will take this value to the opposite side, dividing it, I will get 1 upon 1.6, into 10 to the power minus 19 electrons. These number of electrons will be equal to 1 coulomb of charge. Now just solving it up, 1 coulomb of charge will be constituted by how? I'll remove the decimal. By removing the decimal, I can just multiply by 10 in the numerator. Then this is 10 to the power minus 19. If I'll take it up, it will become 10 to the power plus 19. So this equation now becomes 10 into 10 to the power plus 19 divided by 16 electrons. Why 16? Because I have removed the decimal and I have just put 10 up in the numerator. Fine. Now if I just calculate, it will come out to be 0.625 into 10 to the power 19 electrons, right. Taking it to one decimal place, I can also write it like, I'll take one decimal place out here, I'll say 6.25 into 10 to the power 18 electrons. Why? Because if I'll take one decimal here, it will be over 10 to the power 19. So I can just conclude that if 6.25 into 10 to the power 18 electrons come together, then their equivalent charge will be of 1 coulomb. Got it? Right. Now the same question can be put up in a yet different kind of language, which is very good and very nice. Let us understand what exactly how they can put up this particular question in a different way. Let us see. Now this is another question that we are given with, but it is directly or indirectly same as above. How? The question says, if the charge on an electron is this much coulombs, that we already know. Fine. So what we are given in the question is, one electron carries the charge 1.6 into 10 to the power minus 19 coulombs. How many electrons should pass through a conductor in 1 second? Now time is given to me. I will write given part first. What is all given? Time is given to me to be 1 second. So to constitute 1 ampere current, the current is also given to me. This is represented by capital I. It is given out to be 1 ampere. Fine. So now what exactly the question is? Let us relate once again. How many electrons will pass through just in 1 second so that 1 ampere current can be constituted? So first of all, when we are talking about the charge in coulombs, we need to know how much charge is produced because of this 1 ampere current passing through a conductor in 1 second. And to calculate, we know that I is equal to Q upon T. We have just studied 10 minutes back. I is equal to Q upon T. I have been given I in the question, I have been given T in the question. First of all, I will calculate Q, that is the amount of charge. So putting the values of I and T in the above equation, what do I get? We get the current was 1 ampere is equal to Q upon time was 1 second. So I can say that Q is equal to 1 coulomb. So from this I conclude that if 1 ampere current is passing through a conductor in 1 second, then the charge produced is 1 coulomb. Now it comes as the same as we have done above, that if one electron has this much of charge, if one electron has this much charge, then how many electrons will collectively combine to form 1 coulomb? Same unitary method, right? Now the question will be continued the same as we have done earlier, that if one electron carries a charge of 1.6 into 10 to the power minus 19 coulombs, then 1 coulomb of charge will be constituted by dividing over here 10 to the power minus 19 these many electrons. Next, same as we have done in the earlier question, 1 coulomb will be equal to taking this in the numerator becomes plus 19 and removing the decimal multiplying it by 10, 16 electrons. 1 coulomb once again comes out to be 6.25 into 10 to the power 18 electrons. So, these many electrons will constitute 1 coulomb of charge which was there when 1 ampere of current was passing through the wire in 1 second. Got it? This is another way of asking this particular question. Fine. Let us see what else can we be asked based on this particular topic. Alright. In this question, what the examiner is asking is a current of 0.5 amperes. What exactly is given to us? Given is current. I, this was current. Current is given to be 0.5 amperes, is drawn by a filament of an electric bulb for 10 minutes. Now, time is given to be 10 minutes, right? Find the amount of electric charge. So, what I need to calculate or to find is the charge, the amount of charge which is represented by capital Q. Got it? Now, we already are aware of the formula. We know that I is equal to Q upon T. Out of these, we see that I is given to me, right? T is given to me. We need to calculate Q. But before putting the values in this formula, we always need to recheck the units, the SI units. The SI unit of current is 0.5 amperes. Ampere is fine. The value of time is 10 minutes. Now, this is what we were looking for. It is given in minutes, whereas we need to recall that the SI unit of time is seconds. So, we will be converting it into seconds. How do I need to tell you? Of course, you know that we will be multiplying it with 60 so as to convert it into seconds. This comes out to be 600 seconds. Now, putting the values of what? I and T in the above formula. We get, what do we get? I was 0.5 amperes, Q we need to calculate, T has been converted into 600 seconds. Now, cross multiplying, alright, cross multiplying, Q will become 0.5 multiplied by 600. Removing the decimal, I will get divided by 10. Then, just cancelling it out, the Q, the amount of charge comes out to be 300. Very important, the SI unit, coulombs. The SI unit of charge is coulombs. So, my answer is 300 coulombs of charge. Got it? So, this is something which we need to remember, that we need to convert it into the SI units. That is quite important. Now, let us see the next question. Now, in this question, what is saying? An electric bulb draws a current of 0.5 amperes. Now, what is given to us in the question is, once again, the current is given, that is represented by I, 0.25 amperes. from the circuit in which 300 coulomb of charge is flowing. Now, charge is given to us. Charge means Q, that is 300 coulombs. To find, calculate the time. So, we need to find is the time value, small t. Once again, we know the formula I is equal to Q upon T. Putting the values of I and Q in this formula, both are having their proper SI units. So, I do not have to recheck it again, or we have to convert, we do not have to do it. Simply putting the values, I is given to be 0.25 amperes, charge is given out to be 300 coulombs divided by T. By cross multiplying, I will put up T here, T comes here, and we are left with 300, and this 0.25 comes here, divided by 0.25. Removing the decimal, I will be multiplying above 100, I will get 1 the, I will get 4 the. So, the time comes out to be 300 into 4 is 1200 seconds. This is so called my time. So, you see, we have practiced. First of all, the formula given was I is equal to Q upon T. Initially, I and T were given to us, we calculated the charge. Q and T were given to us, we calculated I, and in this particular question, I and Q were given to us and we calculated T. Fine. I hope you have understood it all. This is all about our current.